Oh, you know what I should say is we are so back. We are so back. We're going to do electricity today. We are not, with this marker, going to do electricity. Hopefully that's not an omen. Okay, we are going to do electricity today. We're going to start out by not trying to say We're trying to not say Not only not trying to, but we're going to actively try not to say that wicked word. Let's do a concept map. I want you to tell me, in your estimation, if you had to categorize electricity into two separate categories, we might even say, that was close, we might even say two distinctions. Well, how would you categorize that based on what you know, which should be a lot because I see you've done a learning adventure. I assume you've done a review, and I know, or I guess also assume that you've done a laboratory activity. What are these two? Good. This is good for you to think about things. Yes. We are so back. Okay, what if we were going to stick an adjective, a reasonable adjective, in front of the word electricity, and we had two of them? What's a sparks electricity? There you go. That's one of them. The other one's a little bit, historically, people have a harder time coming up with this one, and by people I mean students at Crawford Public Schools. What other kind of electricity could there be? So this one, can you guess what the root of this word is? Stat. Okay, yeah, it is. It's related to the word status, and it's related to another English word that is just these first three letters followed by another mystery letter. Something that is static. You might be aware of like static, if your hair is staticky, that you probably use that word, or TV static. But it's also, no, don't say that. It's also used in the sense of like a status, something that is, stasis. Have you ever heard of the word stasis? Okay, yeah, like homeostasis. Exactly right. Are you in med terms? You just know about it. You just remember things. What's it mean for something to be in stasis? Yes. Okay, good. Maintain, or I'm going to put stay. This is the word stay. So this kind of electricity is staying. And that's a word used to describe it. Does the electricity actually stay? No, you know that it doesn't. That's not how things work in science. I'm doing this because everything in science is all about changes. It's all about changes. But the word is based on the word stay, and that's a way we can remember it. What might the other kind be? If this one's staying, the other one might be going. Good. And what might we call the flow of something from one place to another? Current. There we go. So we have now, and see, that wasn't even too hard. We have two, I'm going to actually, to make it a little more symmetrical, I'm going to put flowing. I used to have hair that was flowing, and now it just stays. Now Mr. Meyer has the hair that's flowing. God bless him. I think it's great. Mm-hmm. I liked it, although there are disagreements about that too. So we have kind of two separate. They're not distinct physically. They're not different in the physical universe, but the way that we think about them as human beings is different. And by the way, that word category is exactly what is it category? I think it's just category. That's exactly how we use this word all the time. These are categories. In this case, of what? Of electricity. But anytime you categorize something, the word categorize does not mean separate things into how they are. It means separate them into ways to think about them. So if we categorize, you guys remember Zaboomafoo? Does anyone know about Zaboomafoo? Does no one know about Zaboomafoo? Never mind. It's a little show that my kid watches was from the 90s, and it's about animals. And one of the lines, I'm going to tell you anyway, one of the lines of the theme song says, we all have different names, it's talking about animals, but we're really all the same. And I think that is so cute because it gets at one of the fundamental things about the universe is that these categories are man-made. So this is the same stuff. What is that stuff? Electricity. Yeah. What stuff, though? What physical matter is making it up? Not quite. Oh, getting closer. What's closer than ions? What's closer than ions? Yeah. What particle might mediate this force? No. Let me give you a sentence frame. You got it. The particle, I want you to write this down because this is the way I want you to think about this kind of stuff, because when you get into chemistry, this is going to become very important. The particle that mediates, we'll come back to it. I know you're like, what's this guy talking about? What is the word media? I've never heard anything in my life. The particle that mediates the electromagnetic, we're going to break this down. Break it down. The electromagnetic force is the, say it again, Ada. Is the electron. The particle that mediates the electromagnetic force is the electron. And that's the same particle in both of these cases, which gets at what I was saying about Zabumafu. They have different names, but they are really the same. They are categorized differently by human beings so that we can think about them differently, but they're really the same thing. So is it that this is a lie, that when we categorize things, that's lying? No, it's a real difference, but it's a human-made difference. Does that kind of make sense to you? I want this to be clear to you because this is the case always in science. We, especially science teachers, present things as if there is a physical distinction between these ideas, but in reality, they're man-made distinctions. I don't know how interesting that is to you. I can tell how interesting it is to some of you, but to me, it's very important that you understand that these distinctions are man-made. They're really just the same, but we think about them differently. And they do function differently. It's just that it's easier for us to categorize them based on this. But they are both mediated by the electron. Let's break this sentence down as promised. I'm going to use the color orange. Go Rams. The particle, what's a particle? No, not always. That's an example of a particle. What's a particle? If it is not the same, okay, yeah, particles make up things. Kind of like atoms. Atoms are a kind of particle, or we often think of atoms as particles. What would be a math synonym for a particle? In science, we call it a particle. In math, it's probably called a... No? What in geometry math specifically would we call a particle? Let me draw a particle for you. Maybe you can get it. What might that be in math? A point. They're not the same thing, but the philosophical ideal of a point in math is like a particle. Okay, it's a effectively zero volume entity. So a particle that mediates, what's this word mean? Holy moly. That sounds like we can't understand this because we're little small freshmen. We're 14 years old. Probably some of you are 15 or 13. How does it work?
Only 14.
How old do you have to be to hit someone with a car? Okay, mediate, you could really any age. In fact, probably the younger the better. Mediates means, I want to think of a way to define this that'll be both helpful to you and true. Yeah, someone says control, and I kind of like that. Although what I don't like about it is that it implies that there's some consciousness to it, which maybe there is, and that's not what we're talking about. But there wouldn't, for this to work, there wouldn't have to be. But let's just think of some synonym. I kind of like control. That's okay. Relays is pretty good. Like in a relay race, when you hand the baton off, these are the particles that carry. There, I like that. That carry the electromagnetic force. Do you remember the four fundamental forces of the universe? Let's have a little side note over here. What color should our side note be, Teague? Sidebar. Sidebar, Your Honor. What color should the sidebar be, Your Honor?
Okay.
Come on. Okay. Imagine you get the distinct honor and privilege of choosing the color and you just don't even care. The fundamental forces, this should be a review, of the whole entire universe. We're going to list them in order from strongest to weakest. That is how much force they carry. And also inversely, from shortest to longest. What is the strongest force in the universe? This should be review, and so I'm asking you. That's absolutely false. Gravity is number 4. Gravity is both the weakest, but also the longest range. Okay, number 2 is electromagnetism. That's the one we're talking about today. Which mediates or is mediated by electrons, and it comprises both what we would call the electric force and the magnetic force. They both have different names, but they're really just the same because they are one force, the electromagnetic force, but we categorize them differently. A magnet, you know a magnet. This little guy. We'll do this next chapter. This little guy. Bye-bye. And electricity, which, let me see if I can get my finger in there. They're really the same force, but we categorize them differently like we were talking about earlier. So electromagnetism is number 2. Have we never talked about this before? I'm pretty sure we did when we talked about gravity, but maybe this is brand new to you. Someone have this in their notes, a list? I might be lying. I have definitely talked about this before. I think even this year. I'll trust you, Avery. If you find it, great. If not, we'll talk about it in a little more depth as if no one had ever heard it before. It would be a chart that looks almost exactly like this. I've really only relayed this out to people in one. I've only mediated this information to people in one way. So if you don't have it looking like this, you probably don't have it. It would have been when we talked about gravity. Because guess what? She's on there already. Well, I'll just tell you. Are you ready to write so that you can do this next time? Because this will come up again. Strong nuclear force is the strongest. It's just called the strong nuclear force. And then the weak nuclear force is number 3. So from strongest to weakest, the 4 fundamental forces of the universe are the strong nuclear force, the electromagnetic force, the weak nuclear force, and then gravity. But gravity acts over the longest ranges, and the strong nuclear force acts over the shortest ranges. It's a trade-off. I'm glad you're paying attention in class today, brother. Okay, so these are the fundamental forces of the universe. Each of these forces, when we get into chemistry, we'll talk about things like how these force fields permeate the entire universe and how particles are excitations in the waveform of that field. But that's not really, in my opinion, that's probably just going to confuse you right now. But for now, just recognize that each of these is mediated by a particle. Mediated meaning that it's carried by a particle, and that they allow interaction between objects without those objects touching. Gravity. Remember, we talked about how gravity, this does not have to be touching planet Earth for planet Earth to attract this, right? That's gravity. Same thing with a magnet. This magnet does not have to be touching the board in order to interact with the board. Okay, are you good with this? And by the way, when things do touch, I'm trying to think of something I can safely knock over without having to hate myself after. Yeah, that would be great. Let me just grab one of these. Just the regular old force, if we remember we talked about push forces, that's actually electromagnetism because you might have heard this before probably on TikTok if you have anything like science on your TikTok or your YouTube shorts. Nothing's ever actually touching in the real sense. Like these particles, electrons are repelling each other, and that's what makes it like when it looks like my fingers are touching this and it falls down, it actually is the electrons in my fingers repelling the electrons in this because, I guess that's the next thing, like charges, this is one of the most important things about electricity and electromagnetism. Like charges repel, similar charges do what? This is definitely review because the last thing I told the 8th graders before I went on vacation was exactly this, and they're 8th graders, and I assume I would. So, like charges repel, similar charges, oh, well, that's not even true, is it? That's for the same thing twice. Like charges repel, opposites attract. Just like in your marriage, you need someone who fills in your gaps, so to speak. I'm not a very organized person. I know to you it seems like I am because you are an abject black hole of absolute disorganization. But I am not really that organized compared to other adults. But my wife is very organized, and so we are opposites in that way. Oh yeah, I do. Thank you. Is that better? Is it showing up correctly? Now it's good. Okay. So this is a fundamental truth about, and not all of these fundamental forces have opposite charges, or they don't have charges at all. Electromagnetism has charges. But in electromagnetism, like charges repel and opposite charges attract. So the electrons in my finger which are negatively charged, repel the electrons in that chair, and that's the push force. And so on the basic level, even a push force is electromagnetism. So we talked about gravity, we talked about electromagnetism. These two we will talk about in probably, I think this is chapter 17 and this is chapter 18 when we get there, so don't worry about those for now, other than be aware that on your test you might have to be listing the order of these. Now, let's back it up a little bit, and by that I mean all the way to the difference between static and current electricity. We talked about how these are categories, how they are both mediated by the electron, the particle that mediates the electromagnetic force. But this one, static electricity, would you please define by example static electricity for me? I know exactly what you're going to say, but I will wait for you to say it. Give me an example of static electricity. It's okay. You can. I do want an example because otherwise you're just going to regurgitate the definition from the book. Say it again, Ada. Yeah. I knew it. I knew it. I knew it. This is your sock. These are your Nike dry fits that somehow you can all afford, and you're picking up as your little Nike dry fits shuffle. They're red. I don't know who would ever do that. Probably a Husker. As you shuffle across. This isn't even cardboard. This whole analogy is flawed because of the way it is. Red Nike dry fits. Who's ever heard of such a thing? It's picking up a charge from the carpet. Depending on the carpet and the socks, either it is depositing electrons from your socks and therefore your body into the carpet, or it's receiving them from the carpet. That doesn't really matter. But they are becoming charged, and that charge is, in a sense, staying. It's static. It's a static charge. It's staying on the surface of something. Does that make sense? Does that make sense? Yes. I ask you a third time, Aiden. Does that make sense? So the charge is staying on these socks. When will that charge leave? Will it stay forever? Nothing lasts forever. I'll give you a hint. You touch something, and that charge is discharged, and makes that little noise that I just did. Which is, by the way, that is literally thunder. Have you ever heard thunder? Like that Garth Brooks song?
That's a great song.
That is a great song. I love that song. That sound of thunder, as another little by the way, when someone tells you, oh, you didn't hear lightning, you heard the thunder, they are one phenomenon. You did see thunder, you did hear lightning, they are one thing. We just happen to have in English different words for those two things, so don't worry about that. You can slap a guy when he says that to you, especially if you're a woman. But the little sound that it makes when you touch your brother Cody after you've shuffled across the floor with your Nike dry fits, the sound that makes, this isn't going to work, but pretend it does. You know the sound. You know the sound? The little zapping noise? That's actually thunder. That is the same sound as thunder. It's just smaller, and so it doesn't go, it goes, but it is the exact same sound. Because what causes lightning in real life is just exactly that, except instead of Nike dry fits, it's the Lord's Nike dry fits, which is a cumulonimbus cloud. That's not a good joke. You're going to have to cut that. The cumulonimbus shuffling over the land picks up charge from the ground or deposits charge into the ground, and when that builds up enough, it's the exact same thing, except this is your house here, and so it seems a lot bigger because it is.
Or with the balloons too in your hair.
Mm-hmm. Yes, I wish I had a balloon because I wanted to talk about that. But this is called charging by induction. Charging by induction. So depending on the nature of those charges, whether they're positive or negative, it will then not only pick up maybe a negative charge here, but because this is now negatively charged, it's repelling the negative charges that are in the ground. So the ground takes on a positive charge, opposites attract, and that discharge will happen because of the interaction between those. Now, how is that different from current electricity? This one does what? And this one does what? And what is the equation for this? This will be our last thing. Let's do it in blue. You do know. It's Ohm's law.
Oh. It's R equals
It ain't.
I equals...
It ain't. It's V equals IR. I want you to memorize it this way. If you already did it the other way, that's fine. I'm not here to rewrite the entire thing. Why? Can you guess, though, mathematically, someone who's good at math, why I might like... I'm sorry, you're all good at math. You all have different strengths. We all have different names, but we're really all the same. Why might this be mathematically easier to use than whatever you have, V over I equals R? Exactly. This is easier to manipulate. You only ever need one step to manipulate this. Whereas if you have memorized V over I equals R, you have to do some little bit wobblier manipulations. Where V is voltage, measured in what unit? Volts. I is current, measured in what unit? Amperes. Yep. And I'm going to put this R over here. R is resistance, measured in ohms. And in this case, I'm not going to get, when we do this in physics, which is part of my curriculum now to redo this in physics, we will get into what these units are in base units. Ampere is a base unit of the SI. The other two are not. I forget what they are. I didn't bother to look it up, and your book doesn't talk about it. But for now, just trust that these units will work out. This is easy math, girl. I promise you, girlfriend, this is easy math. You just manipulate. If you could ever do like something like V equals D over T, remember that from earlier in the year, velocity equals distance divided by time. That's harder math than this. This math is so easy. I hope you found on your learning adventure that this math is so easy. Was there also one about electrical power? Okay, so electrical power in that case, electrical power, oh, sorry, we should probably use the right letter. Power equals, yeah, it is IV, but I wondered if it had also the E over T one. Was that, I mean, I know we did that in lesson 5 or 6, power equals energy divided by time. Okay, electrical energy. Okay, and then we also have power equals energy over time. In both of these cases, so the P here, P is power. You know what power is measured in. Good, thanks for letting me know. What is power measured in? Watts. T is time. Lowercase t is always time, measured in seconds. And I think the rest of them are already, oh, and we also need E is, capital E is, you remember from months ago, energy, measured in what? Your favorite, joules. There we go. And then the I and the V are already over here. Which of these equations is the most difficult? Mathematically? Yeah, this one has a division in it. If we want to rewrite it, which is not going to be the end of the world, it's just TP equals E. Now they're all on one level, and you only have to do one step of manipulation. Your book does talk about circuits and batteries, which I assume you learned about in your lab, and if you want to talk about those with me, I will talk about them with you, but I think, as far as I'm concerned, this discussion is over. Do you have questions? Okay, sounds good. Bye.